The paper of the day is Amazon Redshift and the case for simpler data warehouses. This paper presents Amazon Redshift, which is a fast, fully managed petabyte scale data warehouse solution that makes it simple and cost effective to efficiently analyze large volumes of data using existing business intelligence tools. Since launching in Feb 2013, it has been Amazon Web Services' fastest growing service with many thousands of customers and many petabytes of data under management. It discusses an often overlooked differentiating characteristic of Amazon Redshift, that is simplicity. The goal with Amazon Redshift was not to compete with other data warehousing engines but to compete with non-consumption. They believe that vast majority of data is collected but not analyzed. They believe while most database vendors target larger enterprise, there is little correlation in today's economy between data set size and company size. Amazon Redshift was designed to bring data warehousing to a mass market by making it easy to buy, easy to tune, and easy to manage, while also being fast and cost effective. Let's look at the design goals. The first one would be minimize cost of experimentation. It is difficult to understand whether the data is worth analyzing without performing at least a few experiments. Minimize time to first report. They measure the time it takes their customers to go from deciding to create a cluster to seeing the results of their first query. Minimize administration. Amazon Redshift tries to reduce the undifferentiated heavy lifting of creating and operating a data warehouse. They automate backup, restore, provisioning, patching, failure detection, and repair. Advanced operations like encryption, cluster resizing, and disaster recovery require only a few clicks to enable. Minimize scaling concerns. Many data warehousing engines provide parallelization of loads and queries. They additionally try to parallelize administrative operators like cluster creation, patching, backup, restore, and cluster reset. Pricing is also linear and sublinear with dataset growth. Minimize tuning. They avoid knobs and apply techniques to make the ones they do provide, like dusty, with disuse. For most users, the default setting for these knobs are determined by the system would be sufficient. However, advanced users can choose to change it as needed. Following are the lessons learned from Redshift author's perspective. First is design escalators, not elevators. Failures are common when they operate large fleets with many service dependencies. A key lesson for them has been to design systems that degrade on failures rather than losing outright availability. Second would be continuous delivery should be to the customer. Many engineering organizations now use continuous build and automated test pipelines to a releasable staging environment. Third would be use Pareto analysis to schedule work. In a rapidly growing service, operational load can easily overwhelm development capacity. Now let's look at the PS score. Overall, this paper is a decent read, so it gets 8 out of 10 on readability. It's 7 pages long, it scores 6 out of 10 on length. It's an analysis of an existing system with pretty good description but very super high level detail, so that makes it 5 out of 10. Its industry value on learning meter is decent, so it gets 8 out of 10 on each. Overall PS score is 7 out of 10.